Okay, for this lesson, we're going to be talking about angles and radian measure and talking about reference angles, a whole bunch of different stuff, but it's really not too bad of a lesson. All right, so the first thing that I want you to draw out is what we consider standard position. Now, I'm going to be real honest here. I would much rather be standing in front of you right now because I always demonstrate this myself. Usually these are my arms. So picture me with both my arms straight out, and I'm going to be, you would be looking at, I'd be facing your right. Okay. So both arms out this way. When I lift one arm up, this going this direction, I create an angle that has a positive angle measurement. What's super, super important, this right here is always what we call the initial side. I don't know, I just even write that. This is where we always begin. This is your initial side. Always start here. If you go up, it's a positive angle measurement. If you go down, no matter where you end, if you go clockwise, so maybe think of it that way. Clockwise is always a negative angle measurement. Counterclockwise, hopefully you guys even know what that means. Going the direction of a clock goes this way. Opposite of the clock goes this way. So going this way is positive and going down is negative. All right, so the first thing we're going to do is just draw angles. Okay, so what I want to start with is labeling this. So everybody draw an X and Y axis. If this is where we always start, this is 0. Now, if you think about it, this first corner here, this is a right angle. How many degrees is a right angle? If I make it to the up here, that's 90 degrees. If I make it past here over to the next one, that's 2 right angles, where 2 90s makes 180. Add in another 90 degrees. This is 270. Come back full circle. That's 360. This is why there's 360 degrees in a circle, because you're going all the way around. 4 90-degree angles make 360. And the thing is, you can go around as many times as you want. We can go around, that's 360, around again, 720. We can make lots of circles. Okay, we're not going to do that right now though. So what I want you to ask yourself, if this is always the initial, here is 0. 58 is in between what two numbers? 0 and 90. So I'm just going to put this angle, 58, between 0 and 90. Remember, this is the first quadrant. You might want to mark this up too. We use Roman numerals, and we just go around. 1, 2, 3, 4. So this particular angle terminates or ends in the first. Okay. How about 210? So I start here at 0, and it's more than 90, more than 180, but less than 270. So this angle, 210, goes past 180, but it's not more than 270, so it lands in the third quadrant. So this angle goes from here to here, 210 degrees. Okay. Now, what if it's negative? Negative 125 means I'm going to go backwards. But going backwards means This is my first right angle. So 270 is in the same spot as a negative 90 because that's my first right angle. Positive 180 is in the same spot as negative 180. 90 is in the same place as negative 270. And really 0, 360, negative 360, these are all the same. Okay. So how far do I have to go to get to negative 125? More than negative 90, but not more than negative 180. So it stops in the third. So notice we always start here and we just go enough so it's in between the right numbers. Okay. Negative 125 is between negative 180 and negative 90. I just want to know, where does it end? I don't even care where you put it in the third quadrant. As long as you're in the correct quadrant, that is all that matters. All right, last one like this one, 620. So this is getting to what I was talking to before. We're going to make a spiral. If I go all the way around, that's 360. Now, 360, if I add another 90, that's 450. If I add another 90, that's 540. I just keep adding until that's too much, okay? If I add another 90, that would be 630, which is too much. So it just puts me right here. Now, the other thing you can do, subtract off one rotation. If this number is more than 360, just subtract off 360. That's 260. And if you think about it, that's but more than 180, but just a little less than 270. It put me in the exact right spot. So if this way makes more sense, that's fine too. All right, so this is probably one of the most important things that we all wanted to get to in trig with you guys, radian measure. Okay, so let's go back to our circle analogy. See how I can do this here. That's not too terribly bad. Okay, if I were to travel around the circle, I'm going to start at 0 and I'm going to go all the way around the circle. What do we call that? What formula is this talking about? The outside of a circle. That's the circumference. Do you remember what the circumference formula is? 2 pi r. When we're talking about trig, though, we're always talking about the unit circle, which means r is always 1. So the circumference of this circle in radian measurement, 2 pi times 1 is just 2 pi. So if I start at 0, go all the way around, 2 pi is all the way around in radian measurement. So I want you to think of radians like this. I want you to think of a ruler. What are the different measurements on a ruler? If you were to measure how long a pencil is, you could either measure it in inches, or you could turn the ruler around and measure it in centimeters. It doesn't change the length of the pencil. It's just two different units that can be used for the same thing. When we're talking about circles, radian measurement is just another type of measurement, just like degrees. All the way around a circle is 360 degrees. All the way around a circle is also 2 pi radians. All right, so if all the way around the circle is 2 pi, what would just halfway around the circle be? I'm going to take this off. So if I just want to go halfway, if the whole way is 2, does it make sense that if I go halfway across the circle, that's 1 pi? All the way 2 pi, halfway 1 pi. So pi is in the same spot as 180, just like 2 pi was in the same spot as 360. What's in the same spot as 90? If this half is 1 pi, what's a quarter of a circle? Half of a half, pi over 2. So think of it this way. I'm starting at 0. I go to a half pi, a whole pi. What would be in between 1 pi and 2 pi? What's in between 1 and 2? 1 and 1/2, right? In terms of radians, though, it's always going to be an improper fraction. 1 times 2 plus 1 is 3 pi over 2. So what's really important is we start out at 0. Let me see if I can do this. All right, we start at 0. We're going to open it up, open it up. If I get to this, that's up to a half pi. This is more than a half, but less than 1. Everything in between here is between a half and a whole, because once I get here, that's 1 pi. If I come past 1, this is more than 1, less than 1.5. Everything in here is between 1 and 1.5. If I go past here, this is more than 1.5, but less than 2 until I get up here to 2 pi. So it's all about where does this end? In the first quadrant, it's between 0 and a half. In the second quadrant, it's more than a half, but less than 1. Third quadrant, more than 1, less than 1.5. And in the fourth quadrant, more than 1.5, less than 2. So it all just depends on where it ends. So we're going to do the same thing. We're going to graph these measurements and radian measurements. All right, so the first thing I want you to do, draw this out, and we're going to label this. I'm going to put this down below, though. Okay, so this starts at 0. Remember what I said? Going up to this one is a half of a pi. Over here is a whole pi, 1 whole pi. 1.5 or 3 pi over 2, 3 halves. And if I go all the way around the circle, that's 2 pi. So your question is, how many pi's is this? Pi over 4 is 1/4 of a pi. 1/4 is in between which 2? Okay, so we're starting out at 0. It's more than 0. A fourth is less than a half. It ends in the first quadrant. So when you're drawing the angle in standard position, this is the first part of the angle, and where it ends is the angle that's creating pi over 4. I just want to see, where does the angle end? Pi over 4 ends in the first quadrant. All right. Oops. No, I'm not going to do that either. All right. Now, 7 pi over 6, where does it go? I'm going to do this. So sometimes it's helpful to rewrite this. 7/6 is 1 and 1/6. If I rewrite the improper fraction as a mixed number, it's a whole plus another 6. All right, so then we're going to draw. We start out at 0. It's more than a half, so it goes past a half. It's more than one whole. It's 1/6 more than a whole, so it's just a little bit past 1 pi. This one here is this one here, then I need a sixth more. 1 and 1/6 is more than 1, but less than 1.5. So it's in between 1 pi and 3/2 pi. So remember, standard position, I just want to know, where does this angle end? I'm drawing it going into the third quadrant. All right, letter C, negative 2 pi over 3. So now the negative means I'm going to go backwards. Negative 2/3 is less than 1. So I'm starting here on 0. I'm going backwards. But remember, since it's negative, each quadrant is negative a half. So here's negative a half. If I get back over here, this is negative a whole. 2/3 is not a whole. So it's from here to here, starting at 0, going over here is negative 2/3 pi. Probably one of the hardest things to understand is getting over here is 1 whole pi. All the way around the circle is 2 pi. So negative means I go backwards, but I don't go backwards quite a whole because negative 2/3 is not quite a whole. All right, last but not least on this page. Okay, 9/2, so I'm going to rewrite this. 2 can go into 9 4 times with 1 left over, 4.5. So let's think about this. It's positive, so I'm going all the way around, and that's 2 pi. I'm going to go all the way around again. That's 4 pi. Now I need another half. All right, so let's think about this. All the way around, 2 pi. All the way around again, 4 pi. To get back, it should be going straight up. So the angle is all these rotations. Now, sometimes what it helps to do is subtract off the extra rotations. So if I take away 2 pi, that's 2.5. Take away another 2 pi, I'm left with 1/2 pi, which is just from here to here. Remember, the important thing for drawing your angles is where does it end? And it ends straight up. Okay? So this is the drawing of the angles. Sometimes it's helpful just to convert back and forth from radians to degrees. What's in the same position as pi again? What degree measurement? Is 180. So one of the things we do is we can use pi over 180 if we want to change into radians, and 180 over pi to change into degrees. All right, so go ahead and write these two things down. If you need to pause the video, that's fine. Think of this, if you've ever had Mr. Wallace, he would talk to you about factor label. To me, that's all this is. So watch what we're going to do. I'm going to use this fraction bar for pi over 3. I'm just going to extend it. And if this is in radians, I'm going to go into degrees. All right, so I'm going to, and another indication, if pi is on top, I want to cancel it. So I need pi on the bottom, 180 on the top. All right, the pi's cancel. Anything on top can be divided by the bottom. 180 divided by 3 is 60 degrees. Pi over 3 in radians is 60 degrees. These are the same angle measurement. One is in radians, one is in degrees. So if it starts out with your fraction bar like this, just extend your fraction bar, put 180 on the top, pi on the bottom. The pi's cancel. Multiply the top numbers. Divide by the bottom number. 5 goes into 360, 72 times. All right, if it doesn't have a fraction bar, I just extend the fraction bar, put pi on the top, and 180 in the bottom. People struggle with this one because it cannot be a decimal answer. You have to reduce the fraction. If they both end in a 0, I'm going to divide both of them by 10. 15 over 18. Now, what number goes into both 15 and 18 is 3. If I divide both by 3, I get 5 on the top, 6 on the bottom, and I go straight across. Put the 5 pi together, and it's over 6. So if there's no fraction bar, you just make a fraction bar and extend it. Okay? Last one. Extend, make a fraction bar and extend it. Pi on the top, 180 on the bottom. Notice this is negative, so let's not forget about it. They both end in a 0, so they're both going to cancel out the 0. 27 and 18, what number goes into both of those? 9. I'm going to divide both by 9, and this is negative 3, and this is 2. Negative 3 pi over 2. So typically the hardest part of this, people struggle in reducing their fractions. All right, the last part of our lesson is finding the reference angle. So we're going to start by drawing the angle, which is exactly what we just were doing earlier. Draw the angle first. Okay. 320. Now, I'm going to go ahead and just label 0, 90, 180, 270, 360. If that helps, do that every time. All right, we always start at 0. 320, more than 90, more than 180, more than 270, but less than 360. Okay, I'm going to tell you right now, when you are finding reference angles, what I have found to be the most helpful is a highlighter. If you have a highlighter, if you need to get a highlighter, pause the video and get a highlighter. There's a couple words here that are very important. A reference angle is an acute angle formed by the terminal side and the x-axis. Okay, so the easiest part to highlight, which one is the terminal side? Where did it end? Right here. Now, there's two parts to the x-axis. The right side is the positive side, the left side is the negative side. Which part of the x-axis creates an acute angle? This angle here is the acute angle that the terminal side makes with the x-axis. I just want to know, what is this angle between 270 and 360? Acute means less than 90 degrees. Okay. What's 360 minus 270? Oops, this is not 270. This was 320. My bad. Okay, this is 270. The angle here is 320. This angle here is 360. How many degrees are in between? We just subtract. When you're in the fourth quadrant, you just subtract from 360. My reference angle is 40 degrees. Okay. All right, 135. So what quadrant is 135 in? More than 0, more than 90, but less than 180. My angle's right here. Then I'm going to grab my highlighter. I want the terminal side, so right here, and the x-axis making an acute angle. This time I need to go to the left to make an acute angle less than 90. So if this is 135 and this is 180, how many degrees are in between? 180 minus 35, my reference angle, RA, is 45 degrees. Okay. Negative 230. All right. So we're starting at 0. Negative means I'm going backwards. Negative 90, negative 180. If I went to the next one, that would be 270. That would be too much. So I'm in the second quadrant. Now I want the terminal side. Which part of the x-axis, the positive side or the negative side, creates the acute angle? Going to the left. This is negative 180. This is negative 230. My reference angle, how much is in between? 50 degrees. Now, acute, think of it this way. My angle is less than 90, but acute angles are also positive. So they're in between 0 and 90. It's the positive acute angle. So make sure your reference angle is always positive. Okay. Now, almost done. We're getting close. 410. It might help you guys just to subtract anytime this number is more than 360, subtract it off. 50 degrees. It's like going all the way around for 360 and then another 50 degrees. I want the acute angle between the terminal side and the x-axis. Well, how many degrees did we just say this is? My RA, my reference angle, 50 degrees. Last slide. We have to just do the same thing, but now it's in radian measurement. So we're just going to draw the angle, find the reference angle. Okay, so let me just review. This is 0. This is a half pi. This is a whole pi. 3 pi over 2, or 1.5, and 2 pi. Okay. So I'm starting at 0, 2 pi over 3. More than a half, but less than 1. Right here is my angle from here to here. Okay. So I want the terminal side and the x-axis that creates an acute angle. Now let's think about this. This right here is 1 whole pi. If from here to here is 2/3, how much more makes a pi? If you have 2/3 of a pie eaten, how much is left? My reference angle is 1/3, pi over 3. I have 1/3 left. With radians, these two will add up to a whole. Okay? If this is more than a half, these two have to add up to a whole. Okay, negative 5 pi over 6. This is negative. 5/6 is less than a whole. So I'm starting out at 0, going backwards, but I can't get quite to a whole pi. This is negative 5/6. I want my terminal side and the x-axis that makes it acute. Now, if from here to here is 5/6, how much more do I have to make it a whole? My reference angle is 1/6, or pi over 6. All right. 11/6. I think with radians, it's helpful to rewrite it as a mixed number. 6 goes into 11 one time and 5 left over. 1 and 5/6. Probably the most difficult part of radians is the fraction part. If you understand fractions, this will be very easy. All right, so I'm starting at 0. I'm going over to 1 pi. I'm going past 1.5, but I can't go all the way around. That'd be 2. 1 and 5/6 is almost 2. So I'm going all the way around and almost to a whole circle. To find my reference angle, I need my terminal side and the part of the x-axis that creates an acute angle. So this is 1 pi from here to here. This is 5/6 from here to here. How much is left to fill in the pi? 1 pi over 6. Last problem. 4/3 is 1 and 1/3. So if we open this up, always starting at 0, I go all the way over to 1. I go past 1 by 1/3. Now this is important. Here is where I end. Here is my x-axis making my acute angle. Remember, from here to here is 1 pi. How much past 1 pi did I go? 1/3, pi over 3. So my reference angle is just this little corner here. How much I went past a pi, pi over 3. And that's the end of the lesson.